Hello everybody, welcome back to Handmade Runes, where we code our own graphics applications from scratch in the Odin programming language. This is session 3. We will focus on performance measurement and timing. We won't be doing too much of Win32 in this episode. We're closing in on finalizing our platform layer. Probably the next session will be the last one that we dive into to Win32 API stuff. It will be about the input, capturing the input. Okay, so before we continue, there's some stuff that I would like to clean up from where we were last session. Just a bunch of cleanups, and we'll talk about frame buffer a little bit. I've since posted another video in my channel about drawing into the frame buffer. If you haven't seen it already, you can check it out, and we'll dive a little bit on that topic again in this session. We want to do it a little bit differently here. Okay, so let's just move this up here. So the first thing I noted was that we can actually just make our pixels U32, and we'll cast that into a pixel in some other way. And we don't actually need this alloc here. We can actually just use new, right? So we need this new of this type, and that's it. It computes what it needs in terms of like how many bytes it needs to allocate, and it just returns the pointer. Yeah. So, and then also I want to just switch this to U32 because we're gonna do a lot of stuff with width and height that's gonna mesh better with U32. It's a bit wasteful because we won't need the full span of it. It's never gonna be more than that. But it's just a lot of computation that involve U32, and instead of casting all over again all the time, we'll just have it that. Let's see. So in resize, so let's see, BI width, oh, these are unsigned, these are signed 32, so we do need to do this because ours is unsigned. Alright. And then in here I can cast this to a pointer to pixels for now. Oh, actually we don't need to cast it at all in this case, because now it is going to be just a pointer to an array of U32s. And then in here we're gonna take this pointer for now and just cast that into a pointer to pixel. We're gonna change this a lot anyway, but just for now, don't need that. Okay, so that's gonna be the first change. Let's see if we broke anything. We're still going strong. Everything's working. Resize, etc. I also like to we had that initial width and height. I want to bring that into the application also. Oh, and by the way, we don't need this pixel size now because we were only using it to compute the size. The size of the allocation. Oops. Yeah. Okay. And we can start with something a bit smaller, just so it fits on the screen here. Okay. Are we? Alright, yeah, so see, we're using the application dot whatever a bunch of times here, and now that I moved it, then I'll need to do application dot whatever. So instead of doing that, we can just decide to using application right here. Okay, and then we don't need this, and we don't need this, and we don't need this, and everything should still work. Another thing is the default context. We actually don't need to get it here because this is a regular outing procedure, so it already has an implicit context. We could just grab that. Right, let's see. Still no go. Using application. Application has initial width as initial height. So what do you want? Undeclared name in window. In here, initial width. Oh yeah, okay, so we don't actually need this guy at all because we are setting the width and the height over here. While on this topic, yeah, so we're using application in here also, and we'll be using in here also and in other places. So we'll just bring all those guys up to here, and just for consistency, we'll bring those up also. Whoops. So all our using is in one place, and kind of clean up this place here, and then we don't need application, it's just resize, and we have an update, and actually D word is a U32 if is it? Yeah, it's a U32, so we actually don't need to cast this anymore because we've changed our width and height to be U32. Let's do that, and let's do that. Kind of line it up, whatever. And we have our pixels, and we have our info, and we have our colors. Cool. It's technically should be aligned like this. Right. What else? We don't need application, just is running. Now we good here. Just a bit of cleanup. Can make this like one line. Yeah, whatever. Okay, so it's kind of like showing how actually there's like very little code here, right? Like people say it's a lot, think it's a lot of code to do. We did a lot of binding stuff and we did a lot of like learning about all this stuff, but at the end of the day it's not a lot of code, right? To do the platform layer, can do like a small recap here. Anyway, so we're creating we're grabbing the instance, which is the running process, registering a new class, with here like instantiating it and registering it, capturing the errors, creating a window, capturing errors, handling errors, getting our window global device context, we're showing the window, and then we're entering our main loop while the application is running. We're pulling, like emptying the message queue while dispatching the messages that we get out of the queue. And once it's emptied, we invalidate the entire window. And in here, any time we get a message, we are currently handling just resize and paint and destroy. So when it's destroyed, is running is also so that this guy will exit. We're posting a request message, and on resize we're grabbing the client area rectangle, setting up the width and height of our bitmap info header. Then we're invoking our own resize, which resizes the frame buffer. And then when painting, we're just updating, which updates the pixels. And then we're doing set di bits with the device context from the very beginning, 0, 0, until the very end, width and height, which will be updated by this guy to be these guys. So they're in sync. And then we're painting with these pixels from 0, 0, like from the beginning of them, and we're doing like a height amount of scan lines, like pixel rows. We're using the info, which is all of this guy, such that all our configuration are kind of synchronized with how we're painting, with the width and height and stuff like that. And we're using the default like colors. And then we're invalidating the entire client area region, because we've just updated all of it. That's kind of a short recap of what we're doing. As you can see, it's actually not a lot of code. Okay, so going back to here. So we made a color and a pixel. I remind you, it's we have these two ways of interpreting a pixel. Then we have a frame buffer. The frame buffer will have pixels that are just an array of U32, unsigned integer, which we can reinterpret as a full pixel, which has two modes of interpretation. Either just the U32 value or the color, which is the RGBA. Okay, and in here, on resize, we're just setting the width and height. And on update, we're looping through the height first, and then the width, and then grabbing the pixel that corresponds to where that is, just setting the color in RGB, green and blue, with the width and the height. And this is how we get this guy. Ta-da! Okay, that's kind of short recap. So there's another way that we could do this update. First of all of the stuff that we're doing here is technically render, right? So we'll just move all of that here, and we'll just call it. And what we're gonna wanna do in this session is we're gonna wanna do before like pre-render or post-render. You can call it pre-render and post-render, and we're gonna wanna measure how long it takes for us to render a frame. So we're gonna have like a pre-render here. It's gonna be a proc, right? And a post-render. And currently they're not doing anything, but we're gonna be wanting to, when we get to here, we're gonna wanna print some stuff. Actually, before we go into that, so we have this render thing. We can have another alternative, call it render 2. That's where we're gonna be doing stuff a little bit differently. So what we actually have is we have a two-dimensional grid of pixels. So it would be cool if we could do something like this for a line in lines of pixels, right? For a pixel in line, right? And then like using pixel.color, we're gonna do this guy, just this, right? And we don't have width and height, but we can just do, can call it actually like Y. No, that's the width, so that'll be X, and Y is going to be the height. Yeah, put it before. Okay, so we could do like, this is going to be the Y because it's going to be like the height coordinate, and this is going to be the X. And this is kind of about when we want it to be like loop by reference. So when we set the pixel, it's actually changing the frame buffer, right? So we want to be able to do something along those lines. So how are we going to do that? So obviously we're going to have to change a bit the way we're storing our pixels here, our frame buffer. So what we can do, first of all, we'll call it bits, because this is like the raw bits. And we're gonna go to here, because set di bits to device, and this will be the bits, right? And before I go on, we'll just put the bits also in here. Alright, so I haven't actually changed anything. We're still using the render. We're doing this empty procedure calls that will fill up later, and we're currently using this thing. It's just taking the bits, and we want to be able to do this. So how we gonna end up having like lines that we can iterate over. So what we wanna have, first of all, let's define what we mean by a line. We're gonna do like a horizontal pixel line. And what's that gonna be? That's gonna be just a slice of pixels, right? And as we resize, we'll need to update all of those slices that we're gonna have, because they're gonna be of different length and they're gonna reference different portion of our frame buffer. So we're gonna need to have like all the pixels as like it's gonna be a slice of like a one-dimensional slice of pixels. So we can actually make it like one horizontal line of everything, right? And then we can do like all slices is gonna be a bunch of slices of lines, which are gonna be smaller than this guy, right? This will contain all of it, like the whole thing that we've allocated, not even all of the stuff that we're using, even more than that, actually everything, like the max size, right? So that's going to be all our slices. Or we call it all lines, actually. Yeah. And actually, no. So okay. So this all lines is gonna have to be like a static array, and it's gonna be an array of that contains a bunch of these lines, which in each of those is gonna be like a slice of pixels. But like how many maximum amount of horizontal pixel lines are we gonna have? Well, it's gonna be the max height, right? That's the maximum amount of horizontal pixel lines that we're ever gonna have. And then lines itself is gonna be some slice of lines. So it's gonna be some slice of all of the lines, right? Yeah. So in here we're gonna populate like all of the pixel lines, and we're gonna have to do that every time that we resize. So the line length given this width and height is gonna be it's gonna be just the width in this case. Yeah, we don't need that, but we do need a start and end for slicing, and that's gonna be a U32, and we're just gonna be updating those to be different things. So actually the start is gonna be a U32, they'll start at 0, and the end is gonna be U32 that's gonna start at the width. We can actually do this because width is E32 now. We don't actually need to initialize it because it gets initialized by itself. So this is like the starting point. Our first line is going to be from 0 to up to and not including width. And now we're going to do like a for loop for y in 0 all the way up to and not including our height. So we're gonna do, we need to start populating our all lines for this configuration, right? So the first one, right, I mean on each iteration, on each y coordinate, we're gonna have a line. So all lines is gonna, in this height is gonna be all pixels from start to end. So in the first one is gonna be like 0 to width, and then we say, okay, now we're gonna, once we've done that, we're gonna move everything one step. So width and end is also gonna be plus equals width, and that's it. So now we've populated all of our all lines, right, and which is a static static array that has been already allocated and yeah, okay. And then lines is going to be a slice of all lines. I know exactly how many we're going to have. So lines is going to be all lines, right, from the beginning all the way up to height, right? So now we have lines, and each line in that, so this is a slice, so we can loop over it by reference. It's going to be all the lines that we've populated here, and each of those is going to be a slice of pixels, right, from some start to end. So this is going to be like the slice of pixels, so slice of lines. And the only thing left here to do is we need to populate our all pixels before we can even do all of that. So all pixels is going to be a slice of pixel items that is gonna enclose over this memory that we are allocating in here, and we need some place to do that. So let's have like an init application, because we're gonna need that anyway later. And we'll be doing other stuff in here soon enough, but so we're gonna do like using frame buffer, and now we need to see how we're we need to set all pixels. So it needs to be like the bits, right? The thing that bits points to, which is an array, and then just make it a slice. But we need to cast that into a slice of pixels. We need to reinterpret that as a slice of pixels instead of a slice of U32s. And we can do that with just transmute. And we close that like this. So we're going to transmute in horizontal pixel line. Boop, 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 boop. Right? Because horizontal pixel line is already a slice. It's a slice of pixels. Right? So we want to take this entire array and reinterpret it as a slice of pixels. Alrighty. So let's see if we compile. We'll still be rendering with the old way, just to make sure we haven't broken anything. Let's see. We have. So application Odin. First of all, we need to call this guy in our platform layer. Somewhere in here, like at the very beginning. So init application, and we are using application, so we don't need to reference that. Okay. In our application, in line 30, yeah, line 30. Oh, yeah. Next one. Undeclare pixels. Oh, no. It's a slice of pixel. Unfilled pixels. We're still using pixels somewhere. In application 32, 32, 30. Oh, right. You need to assign that to bits. And all pixels. Typo. Where is my typo? All pixels. Alright, so we haven't broken out anything with the old guy, and now we'll see if we can do the new guy. We'll do that just by changing this to number 2, which is this guy. Let's see. Haha! Getting exactly the same. Alright. And we'll soon profile between those and see if we get some even performance. But this is way clearer what's going on than this. I mean, you can follow it, I guess. It's not that much of a difference, but for line in lines, for pixel in line, reads very nicely. Anyway, let's start talking about what we're really wanting to discuss in this session. So, what we want to be able to do, and we're going to be following the video that I just made about timing in a cross-platform way. If you haven't checked it out, you can do so right now. You can pause this video and check that video out. It's on my channel. And so basically there's a thing that we're gonna an abstract concept that we're gonna call ticks. That's gonna represent whatever the current platform that we're running on, wherever its concept of the smallest time unit that it can measure. and we're gonna have some get ticks procedure that we can call, and it's gonna be set, and it's gonna abstract over the application, the platform. The platform is gonna provide us a procedure, basically like a callback, that we can call back to. It kind of goes against the whole, the unidirectional concept that I discussed in the application design, but there's like exceptions to the rules, and this is one of the very, very few. Currently it's going to be the only one. So we're gonna have some get ticks that gonna call back to the platform layer and get us some number of ticks. It's gonna be some integer, and before we render we're gonna need to populate some before value, right? And at the after we're gonna do the same. I'm gonna populate some after value, right? And this is gonna, then we can do like a delta. If I can type delta, it's gonna be the after minus the before, right? And let's just start with that. Oh, well, okay, so let's assume that we have that. So we're gonna have like how many ticks did this frame took. And now we're gonna be wanting to convert that to, say, microseconds or milliseconds. So for milliseconds, we're gonna want to be able to do something like milliseconds per tick, right? Which is going to be some fraction, and we're going to be wanting to multiply that by delta, right? I'm going to want to do the same for microseconds and have a microseconds per tick times the same delta. This will give us how many microseconds. This can be like integers, unsigned integers. This could be like floats. That's fine. The delta is going to be unsigned integer. In fact, let's start flashing those out. So we're going to have before. If I can type, yeah, before and after, and delta are gonna be a U64 because this could be like in the millions, right? And then we want these guys, right? So we want, start with these guys, and we'll do these guys also. So milliseconds per tick and microseconds per tick is going to be an F64, some big fraction. And what did we have here? Yeah. And milliseconds, like a number, and microseconds are actually going to be also U64, so we can do that. Oops. Whoops. Right? So before, after, and delta. Yeah. We're probably gonna like extract all this stuff into some perf or some like timer struct. For now it's fine. just keep it as globals here. We need to populate these guys. We need to know how many, what's the fraction that represents how many milliseconds. It's not going to be even 1, it's going to be less than a millisecond, so it's going to be a fraction. So how many milliseconds, which is in a fraction, per single tick, and how many microseconds. So if you followed my video, you will know how we compute that. So we say that let's just copy that. Milliseconds per tick is going to be 1000 divided by ticks per second, and we're gonna get the ticks per second from the platform. So the ticks per second is going to be something that's going to need to be provided for us. If I can type. Right. And it's going to be a fraction, so we want to do an F64 of this thing. Right. Yeah, because these are also F64s, right? F64s. And of course in here we're gonna have to cast this to an F64 for this multiplication to work properly. And we'll then need to cast it to U64 for the assignment to work. Okay. Cool. So now we need to worry about how we get how many ticks there are per second in this platform, and we need some procedure that we can call back to that gets us what are the current ticks, right? So we're gonna need some platform get ticks procedure, which is gonna be, we'll call it get ticks, all caps. It's just gonna be some procedure that returns a U64, right? So this is gonna be the procedure that we're gonna expect to be given. And we want platform ticks per second, which is gonna be U64. Right. And we're gonna need to store a get ticks. That's gonna be like an instance of this guy, right? And once we got it in application initialization, we're just gonna set whatever we got here, because it's gonna be the same type. And we can also store, because maybe we'll want to use it for some other things, the ticks per second, right? It's gonna be a U64, and so we can store whatever we get from the platform ticks per second in here in our global, and that's it. So we're gonna get the platform ticks per second, and we're gonna get ticks, and these are gonna be the fractions that we're gonna be using for converting between ticks to milliseconds and to microseconds. And again, details on that in the video that I've made. And so let's say we got some microseconds, right? And we could just say that on every frame we're gonna print, which is gonna be crazy, but let's do that for now. So import core fmt fmt print line microseconds per frame, right? Yeah, so we're converting microseconds per tick times our delta. Cool. Alright, so now we need to worry about how to provide these guys from our platform layer. Let's go back here. So we're going to need some procedure. We'll call it win32 get ticks. Right, and it's gonna return a U64. So we need to be able to have some procedure like that, and then when we initialize our application, we're gonna be passing it here. Second thing we need, I should probably just we'll do it here. And also we're going to need a win32 ticks per second. That's going to be a U64. Alright. And we're going to need to pass it here. So we're going to need to set it to something here. So let's find out how we get that from Windows. So we have this thing called query performance counter, and it gets us this large integer thingy. So we need to provide a pointer to this large integer thingy, which, as we'll see, it's going to be a struct, and then we can ask the struct that we pass the pointer to what was filled into it by this call. So that's the first thing. And I'm going to cheat, and I'm not even going to show how to, like, where to get the bindings from. We're just gonna copy it here. So first of all, it is in kernel 32. So we do have a kernel 32 up here. So we'll need so here's our thing, right? But we don't have a large integer. So what's a large integer? We do have a bool, I think. Yeah, we do have a bool. So a large integer is going to be this struct, and I won't show how I got it, but you've already seen it a million times already. So it's just a union. If you look for what it is, it's a union of two structs. One is like a low part and a high part, and another one like that, and there's like a quad part which is a long, which is the whole thing, right? This is just two ways of like getting getting parts of it, but long is the thing that we are gonna be interested in. This is just to satisfy the binding, and we're gonna use what's called the quad part here. And I think we already have a long. We don't have a long. We don't have a long. So a long as opposed to a long. If you go to our types, we don't have a long. And you can guess what a long is going to be. Right? It's going to be twice as long. Right. So that's our query performance counter, and we need to pass to it a large integer. So what we can do in our application, we'll have some, not in application, sorry, in our platform layer, we're going to have some large integer thing that we're gonna be abusing over and over again, just for the purpose of getting what are the current ticks, what's the current counter, right? So we're gonna call it perf counter, whatever. Current ticks. We'll do performance counter because this is the Windows way of calling stuff, right? So now in here, whenever we wanna get performance count, I'm gonna call our proc, right, passing the address to this guy, and they'll populate it, right? And then all we need to do is just return whatever is quad part, right? Whatever is the quad part. But that's going to be a long, which is an I64 as you just saw, and you want to convert that into a U64. It's never going to be negative. I don't know why it's I64. This is a counter that only goes up ever. Okay, so that's one part of it. The second part of it, we want to know, so this takes care of that. We'll now have a Win32 get ticks that we pass, which gets us a performance count using this. Okay, and now we need the Win32 ticks per second. So the performance counter, the query performance counter procedure has a cousin which is called query performance frequency, right? Now look, it takes exactly the same thing. But this time, the thing it will fill in, the information it will fill in into the same type of value is like the frequency, which is exactly what we want. It's like how many counts in Win32 terminology per second, right? So as before, I'm gonna cheat and go to the bindings, and we'll just put this thing here. Right? There's nothing surprising about this. So in our application, but we're going to need some performance frequency thing. That's going to be a large integer, and then we're going to call this with the address of that, right? And then we're going to get whatever is inside of that in the quad part, and it's going to be, we're going to cast it to U64. Okay, so this is going to be our Win32 ticks per second. This is what we just queried, and now we are ready to go. We have passed all the information that we need to here, which will set the procedure into here so we could query it from here and here. And we'll have the ticks per second that we got in here, right? And we know how to do this fancy conversion trick. And yeah, so let's try to run it. Of course, I made mistakes. Performance frequency of current has no filled quad because I mistyped part. Okay, and we don't have a delta apparently, don't we? Delta. Undeclared identity. Delta. Of course, I mistype it. It's not delta, it's delta. Yeah. And what do you know? Here we go. So, microseconds per frame. This is what we're getting in this resolution. That's a lot of. That's. Whoa, of course. Right. So, as you can see, we're right at the border of a single millisecond here per frame, right? When we get here, it's gonna be like more, but we're not even optimizing it. This is without optimization, right? And we'll get to optimization in just a bit. But say we didn't want to print this thing like every single time that we render a frame. We want to do it like every second, let's say. So what do we need to do to get that? So we need basically to take some average. So we're gonna have some we're gonna be accumulating, can accumulate the ticks. So accumulated ticks, right? And we're gonna add the delta that we got, if I can type, right? And accumulated ticks is gonna be also U32. Just gonna start at 0, so I don't need to initialize it. And we're just gonna accumulate and accumulate and accumulate until at some point, if we, let's see, so we're accumulating ticks, and we want to know if the last time that we actually, a very simple way of doing it would be to just say accumulated ticks if it's larger or greater than ticks per second, which we already have as a global, right? If we have accumulated ticks to the amount that is equal to a second or more, then we're gonna do this print, right? And then we'll reset it, right? But we don't. Yeah. So yeah, we'll also need to accumulate some frame count, like how many passes have we done when we accumulate it. So we can do like accumulated frame count. We'll increment it. We'll start with 1 as well. And it'll also be a U32 because why not? U64 because why not? And then yeah, let's see. Well, then we can say average average ticks per frame is gonna be accumulated ticks divided by accumulated frame count. And obviously we're gonna want to reset that as well. So that's gonna be the average ticks per frame. And if we want to know microseconds, we're gonna have to do this same trick. In here, though instead of delta, we're gonna have the average ticks per frame, not the current ticks per frame, which is the delta. And we don't actually need this, we can just do that. Right. And we'll call this average microseconds per frame. It's gonna be the microseconds per tick, which is some fraction, times a fraction which is accumulated ticks divided by accumulated count, which is not going to be a fraction. Well, both of these are going to be, we can make it more accurate while we're at it. Right. Just to be extra clear. Right, so we're printing average of this, and this is gonna be like that. Did I got it right? Yeah. So it's gonna be a U64 of microseconds per tick times the average, which is whatever we accumulated over how many iterations we accumulated it over. And now we'll print it. let's see how that goes. There we go. Now we can see it's not going crazy anymore. Every second we have an average. If I make it smaller, then obviously it's gonna take less time, even on average, etc. This is much better already. Let's try to optimize and see what we get. All right. Yes, okay. These are much smaller numbers now. All right. Let's try to see what would we have to do if we wanted, instead of having microseconds per frame, we want to do like a theoretical frame per second. So, average FPS. So let's think about it. So this is microseconds per frame. So let's think about it. To get an FPS, this is how many microseconds we have for that average frame. So we want to take how many microseconds we have in a full seconds and divide that by how many microseconds that average frame is. So we basically need to do like take 1,000,000 and divide by this, right? That's it. Look at that. We are rendering at 3,472 frames per second on average, which is a lot. So, because it's a lot, we actually maybe don't want to generate so many frames. By the way, let's check, now that we can, let's check this against our old way of rendering. See if there's a difference. Look at that, it's slower. So our nicer way of doing things is actually also faster by some substantial amount, actually. Okay. So we'll go back to our fast one, and we can actually, we'll call this old render, and this is just gonna be, our new thing is just gonna be render. Alright. Now, so we're rendering a lot more than we need to actually. So how do we make it so that we don't actually do that? So what we can do is, so every time this goes in a loop, then we invalidate the region, and we can actually say, well, maybe we can wait here a bit until some time passes and we know that now is a good time to spit out a new frame, because like most monitors are gonna have like 60 frames refresh rate anyway, so we're just spitting out frames that go nowhere. So what would we need to do in order to do that using what we already have actually. So there's a couple of ways to do that, but first of all, let's just think about it. So we're doing like rendering and more rendering and blah blah blah, right? But our monitors is not that fast, so it can't display all that. So it's like displaying this thing. And so say like our monitor has some refresh rate that looks like this or something, right? And we're rendering, and what we want is to say rendering, wait, now render again, and maybe this time it will be faster, I don't know, and then wait, and then render again, maybe it's a bit slower then, and it's gonna be like in these intervals, and it's just gonna do nothing in between. This is kind of where we want to go with this. So how are you going to do that? We're gonna have to, at each iteration after we've rendered, or like before the next time we render, we want to compute how long would we need to wait, like how long is left until the next time the monitor refreshes. So we need to compute that somehow. So, and say our monitor is, say, 60 Hertz, right? So that means that let's say, how many milliseconds is that? Well, actually, we don't actually have to think in milliseconds. We can think in terms of ticks, right? Because we have ticks per second, which is some number, and we can say, well, just yeah, we'll divide this by 60. That'll give us how many ticks are in 1/60th of a second. And that's gonna be like the gap between here and here, like our target that we want to get to. Let's just start with that. So our target ticks per frame is gonna be our Win32 ticks per second divided by 60. Right? And we'll just do that. We'll just reuse it here. Okay, so now we have this target that we want to check against. So what we actually want is we want to see if where we're at plus, wait a minute. So first of all, we need to measure our frame time in here. Like inside of the platform layer, it does its own thing. We don't want to mess with that at all, so we're just gonna be doing that thing here, and we're gonna be doing it a little bit differently. So we're gonna have like a prior frame ticks, and we're gonna have a current frame ticks. right? And before we even get into before we even start the loop, we're just gonna do win32 get ticks, just so we have something to compare against. And our prior ticks is gonna be whatever the current ticks. Yeah, and then our current ticks is gonna be another one of these, right? And there's actually like a shortcut that we can write it in, which looks like this. Some languages support that. So that means current ticks goes to here, and a new ticks measurement goes to here, right? Now we need to burn some cycles here. Now there's a way of doing it with like a slip. There's pros and cons. It's not very accurate when you give it like milliseconds, and then it can actually skip. It's very often it can skip the refresh rate, and then you like getting half frame rate of what you want. So a better way of doing it, by the way, notice that we only measure it once in this. So what this will end up doing is like, so let's see, the first time we go around, we're populating this. By the way, we don't have this, so we need to declare it that a thing like this exists. So the first time is gonna be like the delta is gonna be like nothing, right? But then it's gonna render, right? And then it's gonna loop back, and then whatever it was gonna become the prior, right? And then this is gonna be whatever the current is. So just with this line, there's no time between, right? It's like we're measuring here the time between all the way through the loop up to here and back, right? So it measures the correct thing. So we have this target that we want to say, as long as the delta is below that, just keep going, like do burn cycles basically. And we can burn cycles by basically just doing this. So we can do like an semi-infinite for loop that does this, and we're gonna for as long as the current delta, which is this minus the prior, as long as this is less than so as long as where we're currently at minus this thing is less than the target, so in here it's gonna be less than the target, and then the next frame, Yeah, so we render a frame, and then we want to burn cycles until where we're currently at. So the delta, this guy, these two guys, gonna measure between here and here. So between here and here is gonna be less than this gap, right? So we're gonna do like another tick. Now it's gonna be between here and here. It's still less. I'm gonna do another tick. Now it's gonna be between here and here, right? Because we keep updating the same current frame ticks, right? Until it goes back to here, and then it's either equal or we pass that, and then this will no longer apply, and then we move on and render the next frame. This is like a way of like burning through cycles without actually rendering. It's very cheap, right? Let's just do this. We maybe can look at how to do it with sleep, but it doesn't really work well from what I've tried. Anyway, so now let's see. Current frame ticks, we haven't defined it. Yes, we haven't defined it. Well, we can do this. Ticks per second, of course I had a typo. Ticks per second. Where's my typo? 70. 70. 70. Please. There we go. Okay. So now we're not getting our printouts at all. And the reason is that now, if you think about it, these accumulate, right? It's gonna take a long time until it gets to a full second, right? Because it's accumulating like a tiny fraction, like of some microsecond, like less than a millisecond, some fraction of a millisecond, right? And we're doing this 60 times a second, so let's actually see that that's what we're doing. So we can do import core font, right? And each time we're invalidating the region, we're gonna do a print line from font rendering next frame, right? And declare name from import core. What did I do? Font. In fact, actually, yeah, this one, it will show us yeah, we won't do that. We'll do something else. Yeah, we'll do something else. Okay, so in our application, we're already tracking a bunch of stuff. Let's see. So in here, so what we can do is we're gonna say we're going to record the last time we reported something. So you say we're going to have some ticks of last report or something, right? And whenever we are reporting something, we're gonna set this to be the after, right? Whatever we got here. And it's gonna be one of those. So ticks of last report, and we're actually gonna initialize it here. Get ticks to just set here. Okay, so we have this ticks of last report, and what we want to say is we want to say if, let's see, yeah, so if where we're at the moment, which is after, if the time has passed between that and the last time we reported something is greater or equal to ticks per second, right, then we're going to be doing all that stuff. And also let's also print out the frame count, like how many frames have we drawn, because we already have that information in the accumulated frame count. Frame count. Okay, so we run through some number of frames, we don't really know how many, and let's see if we need to change something. Yeah, I think we're fine. That's right. Yeah. Missing argument in conversion to get ticks. Oh, this is lowercase g. Now look at that. So every 60 frames or so, but we're still printing the average FPS, which is the theoretical FPS. Why? Because you think about it, like in here, like burning through cycles and speeding out a frame, and then coming here and burning through cycles and speeding out another frame. Right? So the time it takes to speed out a frame is very small. So if we take that and average it, even if we don't average it, it's like, it's gonna end up being very, very small, right? So the actual render time, if we were to not do all this sleeping here, this churning, then the theoretical frame rate would be in the thousands. Right? But we're actually averaging this, which is yeah. So every second or so, you can see that we've averaged around 60 frames, right? Yeah, this is about it, I'd say. So we're getting very high frame rates, just so you can see. To get really below 60, theoretically, we need to make this very, very large. Can't even show in the thing here. But anyway, so this is where I wanted to get to. Hope you enjoyed this session. I know it was a bit slow. Next time we'll do input capture, we'll do some more interactive stuff. And that's it. If you enjoyed it, you can click the like button, hit the like button, and if you want to be notified for the next episode, you can subscribe. Thank you. Bye.